Today's webinar, Apache Kafka for Oil and Gas Smart Grid and Energy Utilities, presented by Confluent. As a reminder, you will receive a recording of today's presentation later this afternoon. If you have questions during the presentation, please use the Q&A button at the bottom of your window to type out your question, and our presenters will address your questions at the end. I'll now turn it over to a presenter for today's webinar, Kai Vayner, Field CTO, Global Technology Advisor at Confluent, who is also joined today by John Bledsoe and Dave Klein. So over to you, Kai.
Okay, thanks for the introduction, and I'm really glad that so many people are interested in this topic. I will explore how you can leverage event streaming in the energy industry. So it really doesn't matter that much if you're like in oil and gas or renewable energy or any other kind of business unit here. I think this will be really exciting to see. So I really want to cover a lot of different topics. So here you see I have a full agenda for the next 45 minutes to give you really a high-level overview about what might be interesting for you. And then we can also go deeper in follow-ups and discuss with you about your specific use cases. But the main idea is today in the beginning, I will talk a little bit about actually why customers in the energy industry are working with us around event streaming. And then I will show you a few real-world examples from different sectors of the energy industry. And then I will go more into technical details about the architectures, how you can run event streaming, both in the cloud, but also closer to the edge, on-prem, or even very close to the edge, like in the oil and gas field. And then I will talk a little bit more about the platforms we are typically combined with. So obviously event streaming is great for many use cases, but it's not a silver bullet. And so I will talk about and also show an example how we complement this with other platforms. And last but not least, I will also talk about cybersecurity and safety. That's also where real-time streaming comes into play a lot to ensure that everything is working well. Let me get started with a quick introduction about the evolution of the energy industry. I think, as most of you probably are in this business, I think you know that even better than me. But in general, really, no matter where you're looking at, like different vendors or the analysts, or also the manufacturers from the energy industry, in the end, there's a lot of trends that there is much more digitalization these days. So it really also doesn't matter if you're more in oil and gas and work a lot in the upstream there or in midstream, or it's more about renewable energy, where you really have solar energy on every house in a smart city, for example. So here's a lot of different examples. You see how the energy market is changing. And with changing, it typically means that most of our customers are not just thinking about the energy production anymore, but really more about the software around that, like for a smart distribution, for example. And with that, of course, also provide additional digital services on top of that. And that's in the end what I will also explore today, how this can be solved or helped by event streaming. So the main reason actually why customers are coming to us here is, of course, on the one side, the infrastructure and the use cases are changing. So people are thinking much more about smart grids, and with that, the energy production distribution is often much more decentralized. And also you often have many more smaller producers like microgrids, where even, for example, every smart home is also producing energy from the solar energy. And with that, then it's also much more bidirectional. So not just sending data to the houses, but also getting data and power from there. And with that, the requirements are changing for the energy industry to get more open and flexible and scalable, but still keeping all of that mission critical and secure. And that's actually where we come into play. So our customers typically need to go away from a more monolithic and proprietary technology and complement that with the more modern architectures. And that's exactly what I will talk about today in much more detail. So let me do a quick introduction so that we all have the same understanding. So it really doesn't matter if you know event streaming and Kafka yet. If you do, it's of course good, but even if you don't, you should be able to follow this talk. But I want to set the context right in the beginning. And therefore, there's really, when we talk about this digitalization, a few different kind of new innovations and paradigm shifts. And so that means most people agree that the cloud is a different kind of how you think about data centers. And if you want to do better analytics and decision making, then different algorithms are used with machine learning frameworks and solutions. Mobile first is also very important for many of the business units in the energy industry. But what I want to focus today about is event streaming, to rethink data. And this is also often complementary to these other concepts here, and we will also see that today. But the main point of today's talk is to explain you, by showing a lot of use cases in architectures, why that's such a fundamental paradigm shift. So what we really see is that the future of data is that you think about it as a continuous stream of events, so that you can process the data in motion. For many of the use cases, real-time data beats slow data. And that's really true for almost every use case. And some use cases are not even possible if it's not real time. And that's why event streaming gets so much traction these days. So what is an event? And that's really also on a high level important to define, but the good news is you can define that as everything. So it can be technical events which come from logs, from firewalls, from sensors, but it can also be business information. And this can also be aggregated, correlated information, which you get from different sensors, and then you aggregate them, and then it could be a new business information. And on the right side, you see a few of these examples. Some of them are technical, some of them are more from a business perspective. But in the end, all of that is an event that you want to act on. And in best case, or in most use cases, you want to act on that in real time, so that you can get additional business value or reduce the risk or cost with that. That's the main idea of using events in an event-driven architecture. And so the key point, however, now is that when we talk about event streaming or event-driven architectures, the key point really is not just to send data from A to B in real time. That's actually not a new approach. That's what exists for 20, 30 years with several different messaging systems, right? So this is true for the IT world, where you have message queuing systems, but this is also true for the OT and IoT world with technologies like MQTT. But that's all just publish, subscribe, where you send data from A to B. The real added value comes when you also use the data in real time and analyze it in flight. On the bottom right, you see a few of these examples in the energy industry. So this is something like when you want to do track and trace in real time for logistics, or when you want to process telemetry data from the different sensors in real time for maintenance reasons. And even for more critical things about safety and disaster and so on. But the point is you get all the different information and correlate it in real time. That's actually what event streaming and processing data in motion means. And that's actually what brings Apache Kafka in here. So Apache Kafka is established as de facto standard for data in motion. This means this is built for exactly what I just described, for continuously processing data from different systems in real time. So the core of Kafka is still a real-time messaging system. So you can send high volumes of data in real time. And that can really be millions of messages. We have customers with Confluent Cloud that process 10 gigabytes and more per second with a single Kafka cluster. So it's really for high volumes of data. But Kafka is much, much more than that. So Kafka is also a storage system. And this is what makes it so different from a messaging system like MQTT or RabbitMQ. So with Kafka, you also store the events as long as you need. That can be hours, but that can also be days or even years for compliance or analytics reasons. And in addition to that, Kafka is also a data integration platform to connect both to the IoT world and to the modern systems like a data warehouse in the cloud or something like that. And in addition to that, Kafka can also process the data in real time. And again, that's where the real added value comes from typically. So Kafka, in summary, is much more than a messaging system. It's a combination of messaging and storage and integration and processing of data. And all of that for high volumes at scale in a reliable way 24/7 without downtime and without data loss. And that's what makes Kafka so unique. And that's why so many people use it. And long story short, so it was developed and used in the beginning only by the tech companies, but that's 10 years ago, right? So Kafka is very battle tested. Today, Kafka is used everywhere across industries. And what's even more important, while Kafka was built for processing high volumes of data, that was the initial use case at LinkedIn 10 years ago, why they built it. But today, Kafka is also used a lot for transactional data. So when you integrate with your MES system, with your ERP system, when you process payments, when you send critical alerts about safety issues or cybersecurity incidents, that's all running via Kafka today. And that's why it gets so much traction and is really becoming mainstream. And so here is just to conclude my introduction, a high-level overview to show you Kafka, there is not just a single use case for that and for event streaming. It's really used across industries and across use cases for very different reasons. Sometimes to build a completely new platform, and some other times to reduce the cost or mitigate the risk of in a specific use case. And with that introduction now, I want to explore why it's used so much in the energy industry in the meantime. So Kafka and event streaming became so popular because it combines all these characteristics I said before. So at its core, it's a real-time scalable system, but it's much more than that. It's an open infrastructure, which you can also use for data integration, for data processing. And you can run that everywhere in the cloud, but also at the edge. And still it's open, so you can combine it with all your other favorite technologies from the OT world and with other cloud services. And that makes Kafka so unique with all of these characteristics. So one last point here. So Apache Kafka, that's actually the open source framework. That's what you can use with Apache 2.0 license for free and change everything of the code and so on. But actually what we see, and that's especially true for the energy industry, actually, here often people don't want to build their own solution. They want to buy a product which is open and scalable like Kafka, right? But still with all the things on top of that, like the comparison of a car engine to the complete car. So as Confluent, we are working only with Kafka, but on top of that, we provide the complete car, including security, including safety, including maintenance and monitoring and operations and all these kind of things. And then when you're even going to cloud, then we can even provide a self-driving car, because here you can consume it as a service with mission critical SLAs without even worrying at all about the infrastructure and only focusing on your business problems. So that's just what I wanted to point out before we go into more detail now. And what's also very important, I want to be very clear from the beginning what Kafka is not. So, and this is especially important in the industrial world, right? Because I talk a lot about real time. And real time in the context of Kafka in the IT world means milliseconds. So what you can do with Kafka is you can process data end to end in something like 10 milliseconds or slower. So that's possible, but that's also possible for millions of events. What you cannot do with Kafka is build embedded systems. Like if you want to implement a robot or technology for your oil rig, where it's really about the hardware and the machines. So that's embedded systems. That's like a PLC, a field bus, that's C or C++, for example. So that's other embedded technologies. And so this is really then hard real time with deterministic network behavior with zero spikes. And that's not Kafka, that's not Java, that's not these technologies, right? And so you can connect that, as you can see in this picture. So we, for example, have customers which build a robot with embedded systems, but then they connect that robot to Kafka via the C++ API and client from Confluent. So you can connect it, but the embedded system itself, that's not Kafka, so that's other technologies, which is much more low level. And this is really what I want to clarify when I talk about real time today. It's in the end soft real time, which means it's 10 milliseconds or slower, right? For most cases, it's still real time, but that's more from an IT perspective. And to map that to a use case, and I will go much deeper into architectures later, but that we already have an understanding from the energy industry. So here it's more about oil and gas and the shipping industry, but the same is true then if you are in another energy business. And so here you see such an overview about the world, let's say, right, or different countries, and then the ships, and you have a lot of different use cases here, and a lot of data you have to process. And what you see here in green is several kind of different options how you can leverage Kafka for event streaming to process high volumes of data in real time and connect different systems. And this really depends on the use case where you run that. So if you take a look at the bottom left, you see a ship. And in some use cases, you want to process high volumes of data at the ship itself, at the edge, disconnected from the rest of the world. And in that case, you deploy Confluent to the ship to do the processing there. And this can be either just pre-processing and filtering before you replicate the aggregated relevant data to the cloud, or this can be more sophisticated edge analytics on the ship or doing other business logic there. This depends on the use case, but the point is you typically don't replicate all the data from all the sensors to the cloud or data center. This is way too costly, and also latency is often a problem, and security and safety. And therefore, this is one use case. On the other side, some of the data should go to a more centralized data center or cloud. So you ingest data into a central Kafka cluster somewhere to run analytic workloads, to do aggregations, to integrate with your other backend systems. And that's important, like you also see on the right side. So you typically don't only collect the data from, in this case, the ships or any other energy machinery, but really you combine that and also integrate it with other systems like your SAP ERP system or some other technologies from the IT world. And then you correlate all of that information in real time to provide additional business cases, like for logistics, for track and trace and routing, just to give you one example here. So, and with this introduction here, you see that event streaming can be used in many different flavors, either at the edge or just in the data center or cloud. Or in many cases, it's actually a combination of that, where you run Kafka, in this case, on the ship at the edge, but also in the cloud, and then you have a bidirectional integration between both. All of that is part of the Kafka infrastructure. And with that overview about event streaming with Kafka, let's now go deeper into the use cases. And so intentionally, I have chosen a few different examples across the energy sector. The first example is E.ON. So that's a pretty big energy company in Europe, mainly I think in Germany and in the UK, but also in other countries. And they have presented at a former Confluent event where they explained how they are transforming their business, as you can see here on this picture. In all my examples, I show screenshots from the presentation from these companies. It's not my screenshots or slides, right? And so here E.ON presented how they are moving away from a system-centric to a more distributed infrastructure, and also more to smaller scale and distributed systems with microgrids and so on. So this is a complete shift of their business. And on the next slide now, you see their architecture and how they implemented that. So they have built what they call the E.ON IoT cloud streaming platform, where they're running event streaming with Confluent on, in their case, a Kubernetes cluster in the cloud. And with that, they're consuming and collecting data from all these different interfaces they have. And this is a technology from the OT world. This can be from where they produce the energy, but this is also connected, for example, to the smart building or smart home. And they collect and aggregate all of the data to provide business on top of that. And this can be things like selling the energy which one solar energy house produces and sell it to the neighbor. So they're going much more away from just selling their own energy, but more into a distribution center for energy also from other energy providers. And in addition to that, they also provide a lot of other digital businesses on top of that to be more innovative. And the heart of this infrastructure is Kafka and event streaming, because for many of the use cases, it's high volumes of data, and it has to be processed in real time, and it has to run 24/7. And that's the obvious characteristics where Kafka comes into play. Another example, and that's from Germany, and that actually was presented last week at a public event from Leipziger Stadtwerke. So that's a public utility in Germany, which is taking care of a specific region around Leipzig. So one specific state in Germany from the public sector. And here you see they are doing more or less the same thing like E.ON before. So they have built a central nervous system around Apache Kafka. That's what you see in the right architecture, the long green box in the middle. So you cannot read anything on that, but that's not the point. The point is that they're connecting to a lot of different systems, both from the OT world, where they connect to the different machines and sensors and devices. And on the other side, at the top of the picture, they also connect to the IT world, where they have their business applications running. And here's the same story. So they do data integration, data correlation, and data processing in real time at scale in a reliable way. And on the left side, you see in this case, so they of course also have to integrate with many different kind of concepts. Like this is not just about power plants anymore. So this is really shifting to more renewable energy, like solar, and also it's about smart grids or even microgrids. And so they have built an architecture to integrate all of that for many different use cases. And what's also interesting about this Kafka architecture, this is actually the digital customer interface. So they are not just connecting their internal systems, so they're also connecting to the grid operator, to the housing industry, to end consumers, and to industrial consumers or customers they're working with. So this is really the interesting part, right? It's not just an internal system, but connecting to many internal and external partner systems. The next example is Day One Energy from the US, from the oil and gas industry. This is actually also pretty new information. So this was presented last week at the Energy and Data Workshop. And so here you see again a screenshot from that, where Day One Energy presented about how they are using Confluent. And here it's a little bit different than the past examples, because here on the one side, as you can see in the middle, they are running with Confluent Cloud. So that's for them a fully managed service. They just consume the infrastructure and focus on their business problems. So this is running in the cloud. And in addition to that, and that's maybe here the even more interesting part, they're also deploying Confluent at the edge, as you can see on the left side. So in this case, they're working together with Confluent and one of our hardware partners, which is called HiveCell. So HiveCell are these small black boxes. And on these black boxes, you can then pre-install software. And that includes the Confluent platform with Kafka and Kafka Connect for integration, but also other applications for business logic and maybe other frameworks. And then you can deploy that at the edge, like at the oil rigs, for example. And with that, there is in the end then on a high level, two use cases. Number one is that you collect the edge data via Kafka and pre-process it, and then you replicate it in real time to the cloud from all of these different edge connections. And there you can then do your analytics in the cloud. But in addition to that, the edge typically is much more important. And so you also do edge analytics, like applying analytic models at the edge to reduce the cost, to make predictive maintenance and quality assurance, and many other use cases, depending on what exactly is your problem. So the key part here also is that this is both vendor agnostic regarding the OT world, like the pumping and operation systems, but also regarding the cloud infrastructure, where you can run on different clouds. And the main idea is that you build infrastructure once around event streaming, and you can run it both across different clouds and data centers, but also across the edge. And in many cases, and also Devon presented that, so they are not just using HiveCell, but in some cases, they are also using other hardware where they're running Kafka on. So I think this is really also a pretty exciting use case, end-to-end with Kafka at the edge and in the cloud. And the last use case I want to show here, so that's Tesla. So when I talk about that in the energy topic in Germany or in Europe, and most people are surprised that I'm mentioning that, in the US it might be a little bit different because Tesla is more present there. But if you take a look at the earning calls of Tesla in the last quarters, actually, Tesla is getting more and more into the energy business. So yes, they are selling cars and it's great cars and they talk about self-driving and all these things. But in the end, they are also investing a lot into their energy business. And this includes many different business models, like that you have solar energy and photovoltaic on every house where you can buy that. And then you have the battery packs where you store and persist the energy until it's used. And in addition to that, they're also now going into the insurance business to complement that. So they have a lot of different businesses, but energy and IoT is really big for them. And Tesla is also, I think, probably one of the biggest public users of Apache Kafka. So here you see a statement, they use Kafka for trillions of messages per day for IoT use cases. And here, like for the others, we share the slides afterwards with the link. So Tesla also blogged on the Confluent blog where they describe in much more technical detail how they use Kafka for all of these IoT use cases. So that's really exciting to see Kafka being used really across these kind of sectors in the energy industry. With that, let me now talk a little bit more about the architectures, because that's also super important to understand in this industry, because there is not a single architecture, right? You need to know what your problem is and what your use case is, and then you can define the right architecture. Here's a few examples more from a global perspective. So, but my point here is not that you can roll out Kafka or Confluent across a continent or across the globe. But the point is that there is different architectures. Like at the bottom left in yellow, you see an aggregation scenario. So this is the example I showed from Devon, for example, before, where you have very small deployments at the edge, for example, in a small Hive cell. And you do collection and pre-processing there, and then you replicate it from all the different edge sites into a big Cloud Kafka cluster where you do analytics and so on. So this is one use case. Another use case you see at the top left in orange is where it's really about the most mission critical workloads. This means you want to achieve zero downtime and zero data loss, even if disaster happens. So even if a complete data center or cloud region goes down. And that's what we provide with what we call the multi-region clusters. So there you can stretch one single cluster across regions. And with that, you have guaranteed business continuity, even if a complete data center or cloud region goes down, and you will not lose any data and your business continues to run. And on the right side in blue and with the arrow colors, you see that we also can have use cases where it's global, where you replicate some of the data even between continents. And with this now in mind, you simply have to understand your use cases and what's the right architecture for you. Because of course, all of these use cases and architectures have their trade-offs. In best case, everything is zero downtime and zero data loss, but that's of course also more challenging and more costly. And so we are happy to discuss with you what we recommend for your use cases. And if we take another perspective on that, so here is now an architecture for energy production and distribution with a hybrid architecture. The top is in the end where you're running some business logic in a data center or cloud. In this example, I use AWS just as example. And here we have things like our applications for real-time asset management, or on the right side, you see that we integrate with third parties like for payment processing, because in the energy industry, you often don't want to implement that by yourself. And for that reason, you work together with a partner. So that's the traditional IT world. And then at the bottom, you see where we are going closer to the edge. And this can be maybe more a local data center, or this can really be more or less in the oil and gas field, for example, where we do data processing at the edge. And then these different infrastructures are connected via the out-of-the-box Kafka integration, where we provide the technologies to replicate data between the different sites in real time at scale, because that's also only Kafka for the replication between these sites. And now if we go now a little bit closer to the on-premise side, like in this example where we're talking about upstream and midstream, like in the drilling and operations and so on. So here is then a Kafka cluster, which is running typically closer to the edge where the drilling is going on. And here then you have a few applications running for that, like maybe you have the upstream operations management product from SAP or whatever it's running there, right? The point is then, this is still a mission critical workload running here. And in addition to doing the mission critical workloads, like you see at the top right, you can still replicate data to the cloud. In this case, on the right side, you see for the real-time supply chain management, this is also where we have partners which have solutions also built on Kafka. Because in the meantime, all of these software vendors, and it's no matter if it's the ERP vendors, the MES vendors, or the retail vendors, many of them have the same challenges as the end users and enterprises in energy. They need to process more data reliably in real time. And that's why many of these products are also built on top of Kafka. And so this is now an idea more from the on-premise data center. And now if we are going even closer to the edge, like this really means outside a data center, then we still see even Kafka running here, like we have seen in the example of Devon Energy, right? Where you deploy Kafka in these small boxes somewhere in the oil rigs or something like that. And so here you see also why people are doing that. So in many of these cases, it's a disconnected edge where you, for internet connectivity issues and network issues, or often also for security reasons, you want to be disconnected. But still you need to process high volumes of data from all the sensors and PLCs you integrate. but you can do that without an internet connection. And that's a huge added value why people deploy Kafka at the edge, right? And it's not just where you produce the energy. I mean, here's just one more example, more about, in this case, about downstream, where you have an intelligent gas station. So it's the same story here. And this is an example we are actually working on right now with many different companies across industries. So you might be surprised, but we're working with customers like restaurants, where they have thousands of restaurants and want to do edge analytics. Or where we're working with different retailers, the same like here in the gas station. And the more and more you digitalize it, for both latency reasons and internet connection reasons and cost reasons, more and more of this is processed where it happens, like in a retail store or in a gas station. And here it's about more advanced use cases like real-time inventory and intelligent pricing. Or when the customer is paying for the bill of the gas, maybe you want to upsell something, you give it a coupon. Like on the right side, and this is also where you see, this is only working real time if you do it with location-based services. When the customer has left the store, you cannot upsell anything anymore. Or on the right side with the C1 example, you maybe only give him a coupon for the car wash if the car wash is not in use, right? Because then you can make money and you can make the customer happy. And this is where you need to correlate all of the different data in real time to provide the right customer experience and to increase revenue in this example. And that's why Kafka is used across these use cases. And now, last but not least, about the architecture, I also want to talk a little bit more about Kafka and machine learning and analytics, because that's also what we see more and more across the field. So in the end, the high-level story is exactly the same. So you have to process a lot of data, you aggregate, you integrate, and so on, but you combine that with machine learning. And there can be different reasons. This can be anomaly detection based on sensor data like pressure and temperature. But this can also be, for example, for images, right? Like this can be now then for inspection use cases or for quality assurance or predictive maintenance. Whatever the incoming data is, you then correlate the data. And in some cases, you combine that with machine learning to make better predictions and really apply analytic models in real time to the data. And so from a Kafka perspective, this is really straightforward. So if you use a machine learning framework like TensorFlow or anything else, it's just data, right? It's events which are flowing through Kafka. And in addition to your other real-time or batch consumers, another consumer is the machine learning application. And this is true both for model training and also for model predictions. Modern and innovative machine learning products and technologies also have a Kafka interface, like they can connect to a data lake or to a database or file. So that's nothing special here, right? So it's the same like any other Kafka application. And this is especially important, and this is now a little bit, maybe if you know Kafka already a little bit more. So Confluent now also provides tiered storage for Kafka. And with that, the huge benefit is that you can also store data long-term in Kafka, even if it's high volumes, because it's still very cost efficient, because most of the data is offloaded into an object store. And with this principle and architecture, in many cases, you should ask yourself if you really need yet another data lake, like Hadoop, for example. In many cases, you don't need that anymore, because now with Kafka, on the one side, you can process the data in real time for use cases which need that. But on the other side, the events are also stored in Kafka long-term, so that the data science teams can consume historical data to train models directly from the Kafka data, with the benefit of having the data in guaranteed ordering, because it's all event-based and dependent. And so this is really pretty cool and cutting edge for new architectures, where you really should ask yourself, do I need yet another data lake or not? Sometimes yes, sometimes no. So with that, I want to talk a little bit about how event streaming in Kafka is complementary to other integration platforms. And so my very first slide here is really important. So Kafka is not an IoT platform. That's what I really want to point out. And therefore, in many of the use cases you have seen before, the last mile integration to the OT world, like to PLCs and SCADA systems, that's often not done with Kafka directly. You can do that, and there's possibilities, but in many cases, you use another IoT platform and complement Kafka with that. Or if you are working in unreliable networks, or if you have to manage millions of devices. That's not Kafka, right? So that's where you complement Kafka with another product or technology. That's important to understand for the overall architecture and how you build your solution. And with that in mind, well, this is now where Kafka shines, because it's not just a messaging system, but also a storage system. It really decouples the different components from each other. And like you see in this picture, in the middle at the bottom, you see where we integrate with the OT domain, like last mile, for example, with OSIsoft PI. That's what this tool was built for and does very well. And you can connect that to Kafka then, and completely separated from that, you can use another technology or product to build your custom applications, to integrate with your CRM system or do anything else. Each of these integrations and solutions can choose their own technology or product. And Kafka really decouples that and handles the back pressure and does the caching and all these kind of things. That's the beauty of Kafka. And so if we go into the deeper OT world here now, I actually also see many customers building a new modern data historian around Kafka. Because in the old world, let's say in the legacy world, everything is proprietary and monolithic. And that's not really how you can go into the future with smart grids, with open and elastic scalable use cases. And like I said just before, in most cases, Kafka is then combined with other existing technologies you already have in place, like OSIsoft, or maybe like in this case, Siemens MindSphere. The beauty of Kafka is that it's an open and agile architecture. You can choose whatever makes most sense for you. And this is also a step-by-step journey. You don't have to do everything in the beginning, right? So this is what you can do over time. And with this, build a modern data historian at the edge and still also connect that to the cloud like I discussed before. And so let's take a look at the process. This is maybe then more transparent to everyone. So this is a setup where we are starting from the status quo. We have only the OT world, and we have the utilities infrastructure with proprietary PLCs. And on the right side, we have an application. So as next step, you can connect that to Kafka somehow. So you still have your existing PLCs and infrastructure, but you can connect that to Kafka. There's tens of options, including using the existing IoT platform, like OSIsoft PI. Then, however, you can build new applications with modern technologies and maybe run some of them running in the cloud. And you can, in parallel, run your existing infrastructure. And then over time, you can decide by yourself. So maybe you also modernize your existing OT infrastructure with open technologies, and maybe some of them are Kafka-based. So that's a typical flow which we see at our customers, where they do this step-by-step approach to modernizing their existing infrastructure. And existing middleware and IoT platforms are complementary to Confluent and Kafka. So with that, let me quickly talk about an example for how you could build a smart grid for that for thousands of devices. So this is really just now high level to show you the idea behind that. If you, for example, have smart meters and then a device gateway, then you could use and consume the data with Kafka and pre-filter it there. Because this is typically high volumes of data, and most of that is not interesting. So you process it, but then you throw most of the data away and only send the aggregated interesting data to the other system, like an asset monitoring tool. And on a higher level then, if you're in field management, you aggregate it from different sites. And the same story on a higher level, right? Where you can connect to many different systems and then only provide the relevant data to the right side, the asset management in this case. And then on top of that, there is often still a human which monitors all of this, but the incoming data is real-time and aggregated, so that really you can take proactive actions on the relevant data on that. Yeah, well, and then the benefit is not just for you as an operator of the infrastructure, but really you can also provide a better customer experience. Reality today in the energy sector is when there is a power outage somewhere, well, it takes a few hours until the customer gets some information, or sometimes even a day. So if you have all this information in real time, you can at least tell the customer, dear customer, this outage will take 2 more hours. So it's okay-ish, right? You don't need to consume your food from the refrigerator. But if it takes 4 days, then you should think differently. And so this is also important. This is really typically an end-to-end flow, not just about your operations, but also how you can communicate with the customer. And well, this is the last slide of this section. When now you talk about such a use case, then you can choose the technologies you need, as I said before. And what we have built is a specific example for this, where we have built an infrastructure for 100,000 connected devices, and all of them produce data in real time. And then we do not just process the data in real time, but we even use machine learning to use analytic models on that, in our case for predictive maintenance. And this is just one example architecture, and this can be built for your use case as you need with the technologies you need. But if you want to get a better feeling about how this can be done, we have built this as an example on GitHub, so it's open source. You can take a look at the demo. And I also have built a 10-minute YouTube video. If you're just interested in seeing such a demo, just take a look at the YouTube video, which is also linked in the GitHub project. So this is just to give you a little bit of more hands-on experience for the more technical people, where we combine Kafka with different technologies like MQTT and TensorFlow. But the point here was that our intention was not just to build a hello world example. So this demo is really connecting to 100,000 connected devices to really show an example at scale. So now I come to the last section before we go to the Q&A. So this is about a topic which is also important across the industry, right? So cybersecurity, and often also in air-gapped environments. So actually, I mean, cybersecurity is not anything new, right? So the big problem, however, is as long as now we are going more into the modernization, more and more of these systems produce data, and they produce much more volumes of data. And also it somehow needs to get more connected, because if we don't connect our OT last mile information systems or OT systems to the IT world, then many of the new use cases cannot be built. You can only do predictive maintenance if you collect the data and use it in a machine learning framework. Otherwise, you cannot build this benefit. But for that, then you have to be aware that security is a big issue, of course. And the problem is that the most existing security technologies in place, they are not built for that, for high volumes and real-time challenges. And so what we see as a trend here is that our customers complement existing security technologies with Confluent. So again, Confluent is not a silver bullet for every problem, but you can complement existing technologies. And here I can give you two different examples. On the one side, top right, you see QRadar from IBM, and you see ArcSight. That's a very sophisticated but old security technologies. They were not built for scale and real time, right? So they cannot handle all this data from the left side. That's why people put Confluent in the middle to pre-process and pre-filter the data, and then they send it into these tools. On the other side, we have modern technologies like Splunk. Splunk scales very well. Here the problem is the bill you pay. So we see many customers which put Confluent in front of Splunk to save millions of dollars, because you only ingest into Splunk the aggregated data, right? So this is two very common use cases we see in security space. And just to give you one reference example from Confluent, one of our customers is Intel, and Intel has built their cyber intelligence platform based on Confluent and Splunk. So here it's exactly this example. They are using Confluent for doing the data integration and for doing the processing and pre-filtering and aggregations. And then they send the processed data into Splunk to do the anomaly detection and threat detection, root cause analytics, and all these things what Splunk is great in. And therefore, this is really a great example how you can combine all the Kafka technologies together with another product for security. And there is also other, let's say, more lightweight solutions. So this is just one example. And as I said before, for the MES vendors and ERP vendors, the same is true for this kind of vendors. So this is MetaRouter. This is a very lightweight tool to process and filter data in a secure way. And it's built on top of Apache Kafka because it needs to scale and be reliable in real time. Just to show you one more example. And now my last topic for today, I want to talk a little bit more about these air-gapped systems, which is super important into energy business. So when you are like in a factory or at the edge, you typically don't connect directly to the internet. So and in the past, typically this was only Windows machines. Many of them are not connected to the internet, and often they are running very old operating systems that are not supported anymore, and there is no antivirus for that. And so what customers now do, because they need to connect it to the internet for all the advantages like predictive maintenance, They are putting a Kafka cluster in front of these legacy systems where they do all of these kind of pre-processing and analytics, so that in real time you analyze every data that's flowing, so that you can make sure that no cybersecurity threat is happening at the edge here. And to give you one specific example, so on the one side, of course, you can buy specific solutions for that and then combine that with Kafka. On the other side, we also have built one solution which we call Confluent Data Diode. And that's really this kind of deployment for disconnected networks and air-gapped environments, where you still want to connect to the enterprise network, but only unidirectional. And this is what we have built with this implementation. And this is also only UDP, not TCP/IP, because that's not possible in many environments. And that's simply one unidirectional connectivity we provide. It's just what I want to show you as one example how you can also leverage Kafka here. But of course, again, you can also combine it with a hardware gateway or something like that. Yeah, and so last but not least, why are people coming to us for that? Well, on the one side, the use cases I showed you, that's typically not a big bang. That's a journey where you start small, often even with open source Kafka, but then you want to go into production, including support and 24/7 operations. And then you want to deploy more and more use cases around that. Or you want to roll this out across the globe or across your regions. And this is where we help both with the technology and products, but also, of course, with our expertise and support and consulting. And that's in the end what we're doing and why people are coming to us. And also, I mean, Apache Kafka is the de facto standard for event streaming. And the reason for that actually is Confluent, because Confluent was founded by the inventors of Kafka. And then actually they also added these features you need, like security, that was not available before Confluent was founded. And today, more or less, every company is using at least Kafka, and most of them are working together with Confluent for these reasons. We are also doing 80% of the commits to the Kafka framework. So we are really the serious experts in that technology. And this is my last slide. So to summarize our business model, we are only doing event streaming based on Apache Kafka. We are not doing anything else, but therefore we're doing that very well. And with that, we provide you not just the Kafka as the core, which is the car engine, like I said before, but we provide you the complete car, including safety, security, monitoring, operations. And then if you're going to the cloud, we are even providing you the self-driving car, which is really the completely fully managed cloud service of Kafka. And here, my last side note, in the meantime, because Kafka is so successful, there's also other vendors in the market. Everyone is using the term fully managed in marketing. In reality, they are all only partially or self-managed, because you still have to do bug fixing, rolling upgrades, and performance tuning. With Confluent, really for us, it's the only self-driving car where you don't have to worry about that at all. And with that, I'm done. I know this was also a lot of content if you're very new to this topic. So that's great why we also have a recording, right, to rewatch it. But I hope it was a good overview so that you understand better how you can leverage event streaming with Kafka and Confluent. And also feel free to connect to me on LinkedIn and Twitter to stay in touch. And with that, now I hand over back to the team if we have any questions for that.
So Kai, we did have some questions during your presentation, and Dave Klein did answer them in real time. But I think it's an opportunity to talk about the questions and have you expand upon them. So the questions were around the components within the Confluent platform that help in the real-time processing for external systems like Elasticsearch, along with Kafka streams inside of Kafka. And Dave pointed out all the different pre-built connectors that we have. And so I think that, from an, expanding upon those, could you describe, say, the life cycle of well measurement from capture, replication, stream processing, and final destination?
Yes, absolutely. And that's really an important discussion because, as I said in the beginning also, many people think about Kafka just as a messaging layer. The reason for that is that around 5 years ago, most people used Kafka only for ingestion into Hadoop, into the data lake. However, that's really only a fraction of maybe 5% of the use cases today. And so it's important to understand and point out again that Kafka is much more than messaging. And for that, it's also key that Kafka has technologies like Kafka Connect for data integration and Kafka Streams and KSQL for stream processing. And with that, now you can build the end-to-end pipeline with one single infrastructure. So this means when you want to run that 24/7 at scale, you don't have to operate 3 different systems, but you can only run one system, but still scalable and with decoupled components. And if you think about this pipeline end-to-end, you somehow consume the data from the sensors and other interfaces. That's the first step. You collect it in real time. Here, you either use directly Kafka Connect for something like syslog, for example, but some other cases, you also have another IoT gateway in the middle, something like maybe an MQTT broker, or maybe a real IoT platform like OCSoft PI or Siemens MindSphere. So that's how you get the data into Kafka first. And then in most cases, you do either basic pre-processing for filtering or aggregations or something like that. Or even in more advanced use cases we've seen today, you really apply business logic, like for predictive maintenance there. So that's really flowing through Kafka. And while that is happening, you can apply ETL and business logic in real time at scale. And then in addition to that happening there, finally, you can also, of course, send it to other data sources, data sinks. And that can be something like Elasticsearch or a data warehouse, or some other machine learning framework or cloud service. And that's again, typically where Kafka Connect is used. Because, and that's also important, so Kafka Connect and also the stream processing frameworks for Kafka, that's all native Kafka under the hood. So it has the same characteristics. It's highly available, it's real-time, it's scalable, and all of that is true also for integration and processing. And that's all these benefits together why you often build an end-to-end pipeline with the whole Kafka ecosystem. But then, of course, the final destination might still be, for some use cases, another database or another data lake.
Thank you. We do not have any open questions at this point. We still have a few minutes left, so feel free to type in questions and we will take them.
Yeah, and while you're still, no, that's okay.
So basically, I was going to say, Kai, maybe something to talk about is many of our oil and gas customers will have field data, to your point about devices like HiveCell and such. But there's quite often data scientists will need to work on that data in Azure. So they'll need something eventually to be in Azure. And you mentioned stream processing at the edge. Can you talk about how, maybe operations can use real-time information at the edge and maybe data scientists in the cloud?
Yeah, sure. I mean, that's really the key piece I said before about you need to define the architecture in the right way for your problems, right? So in most of our cases, we see different people that want the data, some in real time, some more in batch, like the data scientists. And therefore, a key piece of our architecture is also the replication part, which we didn't talk too much about. But the point is that, for example, in these cases, the pattern is that you do the operational analytics at the edge because it has to have very low latency. But in parallel to that, you replicate all or some of the data to a data center, where then you give it access to, for example, the data scientists or the business intelligence tools, because there you get also the aggregation of all the different edge sites. And this is also again important because this often also has very different SLAs. Like, as I said, maybe the OT infrastructure has to run 24/7, and also the Kafka cluster we run there. But if you have an analytics cluster or a reporting cluster in the cloud, there it might be okay if it's down for an hour, or if you lose a few of the data sets, right? So this is really why it's important that we also have conversations with you if you want to deploy it like that, because there's many different architectures and you need to find the right one for your use cases. But in summary, different business units and people can consume the data at their point in time, how they need it and when they need it, and with the technology they need it. For example, in operations at the edge, this is typically a Java application which is more running like in C or C++ if it's on a Windows server, or maybe something like Java or Go. If you're asking a data scientist in the cloud, well, chances are 99% that he wants to use Python client, and that's possible, and that's the great benefit of that. Okay, and last but not least, really, I know this was, again, a lot of information, so feel free to connect to us afterwards if you're interested or have any questions. And with that, I really hope that this helped everybody and was a good overview for everybody.
Yes, thank you, Kai, for that informative presentation. And thank you to all attendees who joined us today. As a reminder, we will be sending out the recording of the presentation later this afternoon. Again, if you want to reach out to Kai, his contact information is on the screen. So thank you again and have a wonderful day.
Thank you. Goodbye, everybody.